All right, so in Chapter 4, we're going to deal with writing equations. Specifically, we're going to write equations in slope-intercept form. So remember, slope-intercept form is y equals mx plus b, where m, the term in front of the x, is the slope, and the constant term b represents your y-intercept. So here is some examples of equations written in slope-intercept form. The equation y equals negative 2/3 x plus 5 has a slope of negative 2/3, a slope of 5, and the equation y equals 7x minus 4 has a slope of 7 and a y-intercept of negative 4. So in these problems, I'm going to show you a general method we're going to follow to write these equations. Because it's slope-intercept form, the two things you're going to need are the slope and the y-intercept of the equation or of the line. So in order to write an equation in slope-intercept form, the first thing you want to do is determine the slope. Figure out what the slope of the line is. In some cases, they will give it to you directly. You will be given the slope of the line directly. Otherwise, if it's not given to you, you're going to have to either use the formula or rise over run. So if you're given 2 points, you can use the formula y2 minus y1 over x2 minus x1. Or if you can actually look at the graph, you can use the rise over run method to find the slope of the line. The second thing you need is the y-intercept, because again, it's slope-intercept form. So after determining what the slope of the line is, you need to determine what the y-intercept is. Now remember, the y-intercept can be defined in a few ways. First of all, it is the point where the line actually crosses the y-axis. It's also the point where the x is 0. So it's always going to have the coordinates 0, comma b, where the b is the actual number that goes into the equation y equals mx plus b. Now in Chapter 4, Section 1, which is what we're going to focus on, you're going to be given the y-intercept for the most part. In future sections, we're going to learn how to find the y-intercept if it's not given to you. Okay, so we'll look at that. I put the explanation here, but we'll come back to this because, again, in this first section, we don't have to worry about finding the y-intercept ourselves. But finally, in the end, once you find the slope, m, and the y-intercept, then you write the equation of the line by substituting the slope for m and then the y-intercept for b. So let's look at some equations, or some examples to help this make a little bit more sense. So Chapter 4, Section 1. Let's look at this first example. So in example 1, we simply want to write an equation for the line with a slope of 2/3 and y-intercept of 0, negative 5. So this one isn't too bad because we are directly given the slope, and we're told the slope is 2/3. So that's our m. We're going to be plugging that number in for m into our equation. And then we're also given the slope, or I'm sorry, the y-intercept, 0, negative 5. So that's 0, comma b. So technically this negative 5 is the b. So all we need to do is take the form y equals mx plus b and plug those values into the equation. So we have the y equals, our m is 2/3, so we plug that in for m, x, and then plus b. So here, because b is negative, plus negative 5 is the same as minus 5. And so that would be the equation of the line with a slope of 2/3 and y-intercept of negative 5. In the second example, rather than being given the slope and the y-intercept, we're given 2 points. Okay? We're told to write an equation for the line that goes through the points 4, negative 1, and 0, 1. So once again, our first step is always to find the slope. So because we're given 2 points, we can use the formula y2 minus y1 over x2 minus x1. Or I'm sorry, this should be x2 minus x1. Okay. So usually it helps to label your points. So this is x1, y1, x2, y2. And then we can plug them into the formula. y2 is 1, minus y1 is -1, so minus -1, over x2, which is 0, minus x1, which is 4. So 1 minus -1 is really like 1 plus 1, which is 2, over 0 minus 4 is -4. And we can simplify 2 over -4 to -1/2. So there's our slope. There's m. We're going to use that in our equation. But we also need our y-intercept. Well, remember, the y-intercept is always a point where x is 0. So look at this point right here. This point has x being 0. So this is our y-intercept, which always, again, has the coordinate 0, comma b. So our b in this case is 1. So we can go to write the equation. Once again, using the format y equals mx plus b, we go ahead and write our equation by replacing the m with the slope that we found. Here is -1/2 x, and then plus b. Well, here our b is 1, so plus 1, and that's the equation of the line that goes through those 2 points. We're going to look at one more example together. In this example, we are actually given the graph. We're shown what the graph is. So we still need to find the slope first. Now we can do it in 2 ways. If you want, you could use this point and use the formula, or we could do rise over run. So I'm going to do rise over run. Okay. So from this point to this point, I'd have to rise 1, 2, 3, 4, 5, 6 places. So again, rise over run. My rise, as I just determined, is +6 or +6 over my run. So I'd have to go 1, 2, 3, 4, 5, 6. So my run is 6, and I can simplify 6 over 6 to 1. So I have my slope, and then I just need my y-intercept. So again, the y-intercept is the point where the line crosses the y-axis. So here's my y-axis, and the graph, or the line I've been given, is this line, and it crosses the y-axis right here, right at this point. Well, that point is 0, 1. So the y-intercept is the point 0, 1, where your b is actually the 1 part of that. Okay, so our equation, when we write it in y equals mx plus b form, is the following. Y equals, again, our slope is 1, so that's 1x, or you could just write it as x, and then plus b. Our b is 1. So 1x plus 1. And so that is the equation of this line here. This line has the equation y equals 1x plus 1.